Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a very good day to all students. So this is the part 3 of functional properties of materials, chapter 6, week 7 for the subject BMFG1213 Engineering Materials. Again, my name is Ashadi from FKP, then I will be discussing with you all on the part 3, in specific the optical properties of materials. Let's take a look at learning objectives. For this particular part, we have to describe electronic polarization that results from electromagnetic radiation and atomic interactions. We should be able to explain, or you should be able to explain why materials are opaque or transparent to visible light. So what is optical properties of materials? It is a material's response to exposure to electromagnetic radiation, for example, visible light. And of course, electromagnetic radiation is considered to be a wave-like, consists of electric and magnetic components perpendicular to each other and to the direction of propagation. And example, light, heat, or radiant energy, radio waves, X-rays, etc., with specific range of wavelength or lambda. Okay, so an electromagnetic wave, electric field and magnetic field components, and the wavelength relation between each other. All right, move to the next slide. The spectrum of electromagnetic radiation. So this is the electromagnetic radiation represented by colors: violet, blue, green, yellow, orange, red. Okay, so that is the condition of the wavelength of all radiation. In the bracket is the energy represented by each wavelength. We have equation like this one. Okay, lambda is equal to C over V, and from the range of micro to nanometer, we can see the difference in the wavelength, and to the left hand side are the energy levels, wavelength, frequency, etc. So what is electromagnetic radiation? All electromagnetic radiation traverses a vacuum at the same velocity that of light, namely 3 times 10 to the power of 8 meter per second, and this velocity c is related to the electric permittivity of a vacuum epsilon 0 and the magnetic permeability of a vacuum mu through this equation. Okay, and then the velocity of electromagnetic radiation c are a function of a frequency v and the wavelength lambda according to this equation. C is equal to lambda v, and it is more convenient to view electromagnetic radiation from a quantum mechanical perspective. Radiation, rather than consisting of waves, is composed of groups or packets of energy which are called photons. So you can faham what is a photon. Photon is the representation of radiation. Kadang-kadang kita gunakan the term photon energy. So the energy E of a photon is said to be quantized by the relationship E is equal to hv and equal to hc per lambda. H is the Planck's constant, 6.63 times 10 to the power of negative 34 joule second, or 4.14 times 10 to the power of negative 15 electron volt second. E photon, energy of photon, is proportional with frequency V but inverse with lambda wavelength. Okay. Take a look at light interactions with solids. So when light proceeds from one medium to another, for example from air into a solid substance, some is transmitted, absorbed, and some reflected. Intensity, the radiation intensity of the beam incident I0, the beam incident maknanya cahaya ataupun radiation yang masuk, intensity ataupun adalah level, the level of the beam incident to the surface of the solid medium must equal to the sum of the intensities, the summation of intensities of transmitted, absorbed, and reflected beams, and they are all denoted as IT, IA, and IR. And as per this equation, the unit will be watts per meter square. Alternate form when divided by IO, you will get 1 is equal to TAR. Okay, and where T, A, and R represent respectively the transmissivity, absorptivity, and reflectivity, or the fractions of incident light that are transmitted, absorbed, and reflected by a material. So this is the concept. Incident coming in, beam or radiation. Reflected is going to be IR, reflected, dipantulkan, absorbed, diserap, IA, and transmitted going through to the body of the material will be IT, transmitted beam. So we have a few classification of materials based on the light interactions with solid. Number one is the transparent materials that are capable of transmitting light with relatively little absorption and reflection. One can see through them. Translucent materials are those through which light is transmitted diffusely. Dia akan masuk di diffuse. Light is scattered within the interior to the degree that objects are not clearly distinguishable when viewed through a specimen of the material. And we have opaque materials that are impervious, not allowing entrance or passage, impenetrable to the transmission of visible light. So bulk metals are normally opaque throughout the entire visible spectrum. All radiation is either absorbed or reflected. Electrically insulating materials, most polymers are made to be transparent, and semiconducting materials, some are transparent and some are opaque. That is for your kind of information for something related to the engineering materials. And then for atomic and electronic interactions, optical phenomena within solid materials occur due to interactions between the electromagnetic radiation and atoms, ions, and or electrons. The two most important interactions, number one will be electronic polarization. What is electronic polarization? A rapidly fluctuating electric field is one of the components of electromagnetic radiation. So at the visible range of frequencies, this electric field interacts with the electron cloud surrounding each atom to induce electronic polarization, to shift the electron cloud relative to the nucleus of atom. And two consequences of this polarization are some of the radiation energy may be absorbed, and light waves are retarded in velocity as they pass through the medium, and this is manifested as a refraction. So this is the figure representing electronic polarization. And for a second one, we have electron transitions. The absorption and emission of electromagnetic radiation may involve electron transitions from one energy state to another. Only photons, only photons of frequencies corresponding to the possible delta E's for the atom can be absorbed by electron transitions. So there will be changes in the electron transition or electron excitation. And then a stimulated or excited electron can remain in an excited state indefinitely. After a short time, it falls or decays back into its ground state. Okay, ni ground state. Kalau excited ataupun stimulated, dia akan pergi ke atas lah. After a short time, it falls or decays back into its ground state or unexcited level with a re-emission of electromagnetic radiation. Okay, metals are opaque since incident radiation with frequency within visible range excites electrons into unoccupied energy states above EF. What is EF? We have learned in the first part. EF will be the Fermi energy. My apology, this is the third part, right? Third part of chapter 6, functional properties of materials. Third part will be the optical properties of materials. All frequencies of visible light are absorbed by metals because continuously available empty states. So the electron from valence band will move on to the conducting or to the empty states in the conducting band. Schematic A will be the schematic representation of the mechanism of photon absorption for metallic materials, in which an electron is excited into a higher energy unoccupied state. The change in energy of the electron E is equal to the energy of the photon. Re-emission, B is the re-emission of photon of light by the direct transition of an electron from a high to a low energy state. The vice versa definition for both figures. And then metals are opaque to all electromagnetic radiation except to high frequency radiation such as X-ray and gamma radiation. Most of the absorbed radiation is this is X-ray, right? Most of the absorbed radiation is re-emitted as reflected light. Perceived color is determined by the wavelength. Apa yang kita nampak color tu determined by the wavelength distribution that is re-emitted or reflected in figure B. So move on to the next one, optical properties of non-metals. Just now is the metal, which we know that metals are opaque. For non-metals, it can be divided into three different parts: refraction, reflection, absorption. So this is two different things. You must understand this one. Apakah itu refraction and apakah itu reflection? Let's take a look at refraction. Light that is transmitted into the interior of transparent materials experiences a decrease in velocity, and as a result is bent. The phenomenon is called refraction. So we need to understand the index of refraction N, which can be found from this equation: speed of light in a vacuum divided to speed of light in a material. So kalau dalam gambar raja ni, di atas ini adalah vacuum dan di sini adalah in a material. So this is the refracted ray. Adding large heavy ions, example lead, can decrease the speed of light. Light can be bent, dibengkokkan. Okay, kita ada refractive index from this table. Saya tunjukkan sekali lagi. Intensity of transmitted light decreases with distance traveled. Thick pieces less transparent. So these are the average index of refraction. Kalau you nak faham, for certain materials which is non-metals, for ceramic, and then followed by polymers, dia ada refraction index dia yang tertentu. Move on to the next one, reflection. What is a reflection? When light radiation passes from one medium into another having a different index of refraction, ada relation dengan yang tadi. Some of the light is scattered at the interface. Some of the lights are scattered at the interface between the two media, even if both are transparent. Reflectivity R represents the fraction of the incident light fraction that is reflected at the interface. R is equal to IR divided to IO, in which IR is the intensity of the reflected beam, IO is the intensity ataupun the level, the amount of the incident beam. If the light is normal or perpendicular to the interface, then R is equal to this equation. And when light is transmitted from a vacuum or air, in which N1 is equal to 1 on the soul, then it's going to be this equation. Next, what is absorption? Absorption of light involves valence band, conduction band electron transitions, which depend on the electron energy band structure of the material. Seperti di sinilah. So kita dah belajar, kita ada valence band, ada band gap di tengah-tengah, Fermi energy level dan sebagainya, ada band gap energy, and we have conduction band. An electron is attracted across the band gap, leaving behind a hole in the valence band. So elektron daripada kawasan valence band bergerak kepada conduction band, meninggalkan hole in the valence band. So absorbed photon energy will be HV is larger than EG ataupun band gap energy. The maximum band gap energy EG max for which absorption of visible light is possible is given as EG max equal to HC divided to lambda, and 4 times 10 to the power negative 7 meter will be the minimum wavelength for visible light. Then let's take a look selected absorption for non-metals. Transparent materials appear colored. Okay, colored as a consequence of specific wavelength ranges of light that are selectively absorbed. So blue light HV is equal to 3.1 electron volt. Red light HV is equal to 1.7 electron volt, in which incident photon energy or HV is equal to HV or IO coming to the sample. And then we have field states, we have band gap, and we have conduction band. So if E gap is less than 1.8 electron volt, we will have full absorption. So the color can be seen is black. Example of material is silicon and gallium arsenic. If band gap energy E gap is more or larger than 3.1 electron volt, there will be no absorption and it's going to be colorless. For example, diamond. Okay, if E gap in between, partial absorption, material has a color. Boleh jadi macam-macam lah. So that is the relation between band gap energy and the color of the non-metals or non-metal materials. So Color in the case of non-metals, basically transparent materials appear colored as a consequence of specific wavelength ranges of light that are selectively absorbed. The color perceived is a result of the combination of wavelengths that are transmitted. So this is another example of cadmium sulfide. We know that CDS is one of the best material for solar energy or solar energy device. It has a band gap of about 2.4. It absorbs photons having energies greater than about 2.4, which correspond to the blue and violet portions of the visible spectrum. And some of this energy is re-radiated as light having other wavelengths. Non-absorbed visible light consists of photons having energies between 1.8 and 2.4. So CDS or cadmium sulfide takes on a yellow-orange color because of the composition of the transmitted beam. So this is the reason why cadmium sulfide nampak seperti color kuning dan orange. So it is related to non-absorbed and re-radiated energy. So this is the concept for the relation between valence band, band gap and band gap energy as well as conduction band. So ini apabila electrons bergerak ke atas kepada valence band, berlakunya proses light emission. But for light absorption, electron in the valence band is moving or excited to the conduction band and moving or absorb the photon incoming incident beam, and then the electron jumped into the conduction band for making light absorption is possible. Okay. So in semiconductor, or for example, semiconductor oscillator does not have many impurity levels in the band gap. Photons with energy smaller than the band gap energy cannot be absorbed. There are no quantum states with energies in the band gap. So apa itu quantum? Itu kita belajar lebih lah. So quantum is the related to spin, electronic states dan sebagainya. This explains why many insulators or wide band gap semiconductors, of course semiconductor ada wide band gap, ada narrow band gap, they are transparent to visible light, whereas narrow band semiconductors like silicon and gallium arsenic are not. Some applications of optical properties of semiconductor: emission, like emitting diode, LED, and laser diode, LD. Absorption, we have filtering process, for example, filtering application for just like sunglasses, as well as silicon filters in which transmission of infrared light with simultaneous blocking of visible light. So this is where how how many impurity levels the photons with energy smaller than the band gap energy can be absorbed by exciting electrons or holes from these energy levels into the conduction of into the conduction of valence band respectively. So we have incident photon, kemudian absorb photon to the sample from valence band bergerak kepada conduction band. So this is the energy band gap energy. Again, this is conduction band and this is valence band. Application of optical phenomena, we have luminescence. Okay, some materials are capable of absorbing energy and then re-emitting visible light in a phenomenon called luminescence. So what happened is we have incident radiation or incident photons or incident beam, berlakunya electron transition here. Okay, and then some of the case re-emission occurs in which the light was emitted. Visible light is emitted when it falls back to a low energy state if it is between 1.8 and 3.9 volt. Example for fluorescent lamp. In the case of fluorescent lamps, we have a glass coating beta alumina doped with europium, and when we have UV radiation inside there, the white light is not absorbed but emitted, re-emitted during the process. So this is the concept, as well as same goes for fluorescence and phosphorescence. Okay. And then we have photoconductivity, the concept of solar energy or solar energy device. Charge carriers, electrons or holes or both created in the corresponding bands, valence or conduction band, by absorbed light can also participate in current flow and thus should increase the current for a given applied voltage. Example, the conductivity increases. This effect is called photoconductivity. So macam cahaya lah, terhasilnya electrical energy or generation of electricity from sunlight Ini adalah melalui proses yang dinamakan photoconductivity. Kemudian that electrical energy was stored in energy storage batteries or supercapacitor, then being applied, being used by consumers. So we want conductivity to be controlled by light. So one few carriers in the dark, this is semiconductor, but one light to be absorbed, creating photoelectrons. Band gap of intrinsic photoconductors should be smaller than the energy of the photons that are absorbed. So this is related to solar device materials, for example, cadmium sulfide. Okay, macam-macam. Nowadays you have perovskite solar cell, dye-sensitized solar cell, DSSC dan sebagainya. So this is all related to photoconductors or materials that giving the effect of photoconductivity. Of course, materials playing an important role there. Again, application of photoconductivity for semiconductor, apa yang dinyatakan tadi, when no incident radiation, little current flow. But when we have incident radiation, in this case is sunlight, cahaya matahari, berlakunya conducting electron in which incident radiation increase the currents to flow. And example of the material or photoconductivity related material will be cadmium sulfide, salah satulah. Sekarang ada macam-macam. We have a lot of types of photodetector. Photodetector sebab dia yang akan absorb ataupun taking the incident radiation into account, the sunlight, untuk berlakunya proses current flow to ataupun electrical current to flow. Okay, guys, that's all for part 3. Sorry, this is not chapter 12. This is chapter 6 actually. Chapter 6. Previously it was chapter 12. Chapter 6. So we have learned functional properties of materials. Functional properties of materials. This is again I recap chapter 6. This is meant for week 7. I thank you so much. Again, my name is Ashadi from FKP. I put my deep apology for any misalignment, for misleading information that I gave you during the lecture session. I thank you so much, and for anything you can call or ask me by using the email of Ashadi related to this topic at utem.edu.my. Okay guys, thank you so much. Sekian, terima kasih. All the best for your mid-semester examination as well as the future final examination and all other assignment as well. Thank you again and have a nice day. Stay safe, stay healthy. Sekian, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.